Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 22, Episode 89, for broadcast on the 4th of December, 2019. Coming up on SpaceTime, a massive explosion rocks the center of our galaxy, the Milky Way stealing galaxies from its neighbors, and the global storms launching dust towers into the Martian sky. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have found evidence of a cataclysmic flare that erupted out of the center of our Milky Way galaxy, affecting the Magellanic Stream, a trail of gas and stars linking our galaxy with two of our nearest galactic neighbors, the large and small Magellanic Clouds. The massive explosion erupted from the region of the supermassive black hole at our galactic center about 3.5 million years ago, sending a cone-shaped burst of radiation through the galactic poles and out more than 200,000 light-years into deep space. The findings, reported in the Astrophysical Journal, suggest the blast, known as a Seyfert flare, created two enormous ionization cones that sliced through the Milky Way, beginning with a relatively small diameter close to the black hole, and expanding dramatically as they exited the galaxy. This event was so powerful that it impacted the stream of gas and isolated stars which flow into the Milky Way from our two neighboring galaxies, the Large and Small Magellanic Clouds. One of the study's authors, Professor Lisa Cooley from the Australian National University, says this explosion is so huge it must have been triggered by Sagittarius A star, the Milky Way's central supermassive black hole. Located some 27,000 light-years from Earth, Sagittarius A star has about 4.3 million times the mass of our Sun. The massive Seyfert flare must have looked like the glare of a lighthouse beam, suddenly turned on amidst the darkness, shining for perhaps 300,000 years. Cooley and colleagues studied the flare using data gathered by NASA's Hubble Space Telescope and calculated the explosion would have taken place a little bit over 3 million years ago. Now, in galactic terms, that's astonishingly recent. On Earth at that time, Homo sapiens' ancient ancestors, the Australopithecines, were scavenging a living in Africa. The findings dramatically changed science's understanding of the Milky Way. It was always thought that our galaxy was a fairly quiet and active place with a not-so-bright centre. But instead, these new results open up the possibility of a complete reinterpretation of its evolution and nature. Cooley says the blast clearly shows that the centre of the Milky Way is a much more dynamic place than previously thought. The observations mean there's still a lot of work to be done to better understand how supermassive black holes evolve and how they influence and interact with the galaxies they're in.
Seyfert flare is a massive amount of radiation. It's really high energy. It's X-rays and it's extreme UV rays, and it comes out of the accretion disk, which is a disk of material that's actually falling into the black hole. And so this is just this massive burst of energy in it. Usually they go in two directions. They can go up and down, and they're often flying out of a disk of a galaxy. Those observations were made based on a combination of ground-based and Hubble Space Telescope data. And what we're seeing is these really extreme lines. So we're seeing lines from carbon and silicon. They're really, really extreme. We call them high ionization, which means that there's been many electrons have been ripped off these atoms. And the only thing that can do that is a very, very extreme radiation field. We're seeing them in two directions, up and down, and it definitely looks like there was a massive flare coming from the supermassive black hole in the centre of our galaxy to cause such extreme amounts of electrons being ripped off the atoms in the gas.
It's a busy place, Sagittarius A star, even though it's a fairly quiet supermassive black hole compared to others. We've got these huge gamma ray lobes, Fermi lobes, that stretch above and below the galactic disk, which we think are generated by this black hole as well, and a lot of other activity.
Yeah, so we're thinking that it's actually is more active in the past than we thought it was. So we know there's some activity like those gamma ray burst lobes, and there's also emission that we can see in the radio as well. And this particular flare, we think, happened about 3.5 million years ago, and that it actually went much further than any of those other events from the supermassive black hole. So we astronomers were used to thinking of this supermassive black hole in our galaxy as sort of a relatively inactive black hole, because we're seeing much more active ones in other galaxies. But this new observation suggests that it actually goes on and off, and it's been more active in the past than it just is currently.
And it's reached a fair way into space too, some 200,000 light years. That's where the Magellanic Stream is.
That's right. So it looks like it's actually been impacting on the gas around the galaxy, and it must have had a really massive force to be able to do that. So this black hole must have been being fueled by a large amount of material at that time in order to cause this massive flare.
When you say impacting, does that mean there's a shock front there or something impacting the Magellanic Stream?
Impact is from the extreme radiation. So there's X-rays and there's extreme UV rays, and then that's been ripping off these electrons from the atoms really far out. And we just don't usually see it happening that far out.
Is that your clue that this thing was there?
Yes. So definitely we're having a look at these absorption lines that we see in the ultraviolet. And we have to use the Hubble Space Telescope to do it, because you've got to get some really fine detail, but you also have to get outside our own atmosphere, which absorbs UV light. So to have a look for these very special lines in the UV, we have to use a space telescope to do it.
And you were specifically looking for some sort of ionization cones, or what brought you to this? Yeah, so it was that.
Yeah, specifically looking for some evidence of the Milky Way's impact on the Magellanic Stream or on the other surrounding gas, because what we don't understand is why do black holes turn on and turn off in the centres of galaxies, and is our Milky Way special in any way, or did it have a supermassive black hole that looked more like some of the other active galaxies that we see nearby? Did it look like that in the past?
Were you one of the astronomers who were disappointed when the cloud sort of did its circle around the black hole and nothing happened?
Yes, I was.
Me too.
I'm a big fan of big discoveries, and I'm always hoping for more.
Was it a cloud or was it a dismembered star?
I think it was a cloud, personally, but there is a bit of debate about that out there.
Yeah, we all got very excited for a long time, and then nothing. So much for a Christmas present.
Yeah, that's right. We do see sometimes some hypervelocity stars, which are these stars that are travelling super fast.
Just the other day, yes.
Yes, exactly, and they can go way outside the galaxy. Basically, they're on a path to be ejected from the galaxy. They're travelling so fast, so they're always exciting.
The event which caused the Seyfert flare, any ideas as to what that could have been? It was something on the accretion disk, obviously. We don't really know. The accretion disks seem to go up and down, or they turn on and turn off as far as the amount of activity that they're doing. And it may be related to the amount of matter that's falling in. So maybe there was an infall of some gas coming into the galaxy, maybe a little dwarf galaxy, or something else that caused this more infall into the central regions. That would cause the accretion disk to be fueled at a higher rate, and then that can cause flares. That's Professor Lisa Cooley from the Australian National University. And this is Space Time. I'm Stuart Gary. Time to take a break from our show now and talk about our sponsor, the Great Courses Plus. You know, sometimes we all need a break from the constant news cycle, and the Great Courses Plus provides a great escape, and it's empowering too. With this brilliant streaming service, you can pick up a new hobby or build up your knowledge on virtually any topic you want to know more about, like the science of evolution or great palaces of the ancient world, even how-to courses on everything from cooking to painting. There are literally thousands of fascinating lectures to explore, all presented by respected award-winning experts in their fields. And the best part is, you get to escape into this vast world of knowledge anytime, anywhere. There's a new Great Courses Plus lecture series this week I want to tell you about called Skywatching, Seeing and Understanding Cosmic Wonders. And it's presented by one of my favourite lecturers and astronomers, Professor Alex Filipenko. The premise is simple. Get outside and look up. Doesn't matter if it's day or night, by the time you finish this course, you'll know what to look for and have a much better understanding of what's right there above you. This provides a detailed knowledge of the union of astronomy and atmospheric sciences. And as usual, the course is delivered with really high-quality graphics and illustrations, which make it easy to understand what's going on. But of course, you don't need to take my word for how wonderful this course is, because as a SpaceTime listener, we have a special offer for you. You can check out the course yourself for free. Empower yourself with knowledge. Sign up for the Great Courses Plus today. And for our SpaceTime listeners, there's a special all-access free trial to the entire Great Courses Plus library. But in order to get this free trial, you need to sign up using our special URL. That way they know you came from us, and you'll be hoping to support our show. Just go to thegreatcoursesplus.com/space. That's thegreatcoursesplus.com/space. And of course, the URL details are in the show notes and on our website. That's thegreatcoursesplus.com/space. And now, it's back to the show.
You're listening to SpaceTime. SpaceTime with Stuart Gary.
Well, speaking of the Magellanic Clouds, a new study has found that the Milky Way has been stealing satellite galaxies from the Large Magellanic Cloud. Just like the Moon orbits the Earth and the Earth orbits the Sun, and the Sun orbits around the centre of the Milky Way, galaxies also orbit each other, according to predictions of cosmology. For example, so far we know of more than 50 galaxies that are orbiting around the Milky Way. One of the largest of these is the Large Magellanic Cloud, a dwarf galaxy some 168,000 light-years away that resembles a faint cloud in the southern hemisphere night sky. Now, scientists have discovered that several of these dwarf galaxies orbiting the Milky Way were likely stolen from the Large Magellanic Cloud, including several ultra-faint dwarfs, but also some relatively bright and well-known satellite galaxies, such as Carina and Fornax. The findings, reported in the monthly notices of the Royal Astronomical Society, show how the Milky Way is feeding on its near neighbours through a process known as galactic cannibalism. The study's lead author, Laura Sales from the University of California, Riverside, says the results are an important confirmation of cosmological models. These predict that small dwarf galaxies in the universe should also be surrounded by a population of even smaller, fainter galactic companions. Sales and colleagues made their discovery by using data gathered by the European Space Agency's Gaia spacecraft, which was studying the motions of several nearby galaxies. They then compared that data with their own cosmological hydrodynamical simulations. The authors used the positions in the sky and the predicted velocities of material such as dark matter accompanying the Large Magellanic Cloud. They found that at least 4 ultra-faint dwarf galaxies and 2 classical dwarf galaxies, Carina and Fornax, used to be satellite galaxies of the Large Magellanic Cloud. However, through the ongoing merging process, the more massive Milky Way used its powerful gravitational field to tear apart the Large Magellanic Cloud and steal these galaxies. Remember, the Large Magellanic Cloud is a disrupted spiral galaxy, and the monster that disrupted it is our own galaxy, the Milky Way. It's the first time astronomers have been able to map the hierarchy of structure formation to such faint and ultra-faint dwarf galaxies. The findings have important implications for the total mass of the Large Magellanic Cloud and also for the formation of the Milky Way. Sales says if so many dwarfs came along with the Large Magellanic Cloud only recently, it means the properties of the Milky Way's satellite population just a billion years ago would have been radically different from what it is now, and that impacts science's understanding of how the faintest galaxies form and evolve. Now, as their name suggests, dwarf galaxies are small galaxies. They contain somewhere between a few thousand and a few billion stars. The authors used computer simulations from the Feedback in Realistic Environments, or FIRE project, to show that the Large Magellanic Cloud and galaxies similar to it host numerous tiny dwarf galaxies, many of which contain no stars at all, only dark matter, that mysterious invisible substance which scientists know exists because they can see its gravitational influence on the stuff around it. The large number of tiny dwarf galaxies seems to suggest that the dark matter content of the Large Magellanic Cloud is quite large, and that means that the Milky Way is probably undergoing the largest merger in its history right now, with its victim, the Large Magellanic Cloud, bringing as much as 1/3 the mass of the Milky Way's own dark matter halo, the halo of invisible material that surrounds our galaxy. The number of dwarf galaxies the Large Magellanic Cloud hosts may be higher than astronomers had previously estimated, and many of these tiny satellites have no stars. They're just gas and dark matter. Small galaxies are hard to measure, and it's possible that some already known ultra-faint dwarf galaxies are in fact associated with the Large Magellanic Cloud. It's also likely astronomers will discover new ultra-faints associated with the Large Magellanic Cloud. Of course, while dwarf galaxies can be satellites of larger galaxies, they can also be isolated, existing totally on their own and independent of any larger objects. In fact, the Large Magellanic Cloud used to be isolated, but it was captured by the gravity of the Milky Way and is now orbiting around it as a satellite. The Large Magellanic Cloud hosted at least 7 satellite galaxies of its own, including its biggest companion, the Small Magellanic Cloud, prior to them both being captured by the Milky Way, which is now beginning to tidally strip them. There is a Magellanic Bridge of stars and gas linking the large and small Magellanic Clouds, and then, as we mentioned in our last story, a Magellanic Stream linking the Large Magellanic Cloud with the Milky Way. The authors of this study now want to determine how satellites of Large Magellanic Cloud-sized galaxies form their stars, and how that relates to the amount of dark matter mass they have. It'll be interesting to see if they form stars differently to satellites of Milky Way-sized galaxies. You're listening to SpaceTime. Still to come, global storms launch massive dust towers into the Martian sky, and Russia launches a new top-secret spy satellite designed to maneuver towards and study other satellites. All that and more still to come on SpaceTime. One of the big questions in planetary science is how Mars lost its water. There are many theories. And a new study suggests massive global dust storms on the red planet might provide a means of transporting Martian water into space. Dust storms are common on Mars, but every decade or so, something totally unpredictable happens. A series of runaway storms breaks out, covering the entire planet in a dusty haze. And just last year, a fleet of NASA spacecraft were in the box seat for a detailed look at the life cycle of the 2018 global dust storm, the same storm which ended the life of NASA's Opportunity Mars rover. And while scientists are still puzzling over the data, 2 papers have shed new light on a phenomenon observed within the storm: massive dust towers, concentrated clouds of dust that warm in the sunlight and rise high into the Martian atmosphere. Scientists think dust-trapped water vapor may be riding them like an elevator into space, where solar radiation can then break apart their molecules, helping Mars degas. In fact, it may well help explain just how Martian water disappeared over billions of years. These dust towers are massive churning clouds that are far denser and climb much higher into the sky than normal background dust in the thin Martian atmosphere. And while they also occur under normal conditions, the towers appear to form in greater numbers during global storms. A tower will normally start on the red planet's surface as a region of rapidly lifted dust covering an area over 70 kilometers wide. But by the time these dust towers reach altitudes of around 80 kilometers, as seen during the 2018 global dust storm, they may be over 700 kilometers wide. Then, as the tower decays, it can form a layer of dust 60 kilometers above the ground that can be thousands of kilometers across, as large as Australia or the continental United States. The new research into Martian dust towers is based on data gathered by NASA's Mars Reconnaissance Orbiter spacecraft, which can see through the haze using its heat-sensing Mars Climate Sounder instrument, which is specially designed for measuring dust levels. The data, coupled with images from a camera aboard the orbiter, allowed scientists to detect numerous swirling dust towers. Dust towers appear throughout the Martian year, but the Mars Reconnaissance Orbiter observed something very different during the 2018 global dust storm. The study's lead author, Nicholas Heavens from Hampton University, says normally the dust would fall back down to the Martian ground in a day or so. But during the global dust storm of 2018, the dust towers were renewed continuously for weeks. In some cases, multiple towers were seen for as long as 3.5 weeks. In fact, the rate of dust activity surprised scientists. But especially intriguing was the possibility that the dust towers act as, well, sort of space elevators for other material, transporting them up through the atmosphere. You see, when airborne dust heats up, it creates updrafts that carry gases along with it, and that would include the small quantities of water vapour sometimes seen as wispy clouds on Mars. A previous study led by Heavens showed that during a 2007 global dust storm on Mars, water molecules were lifted high into the upper atmosphere, where solar radiation could break them down into particles that could then degas into space. And that might be a clue as to how the red planet lost its lakes and rivers over billions of years, becoming the freeze-dried desert it is today. Scientists still can't say with any certainty exactly what causes these global dust storms to evolve. In fact, they've studied less than a dozen so far. But Martian global dust storms are really unusual, and there's nothing like them on Earth. Still, with time and more data, scientists hope to better understand the dust towers created within these global storms and what role they could play in removing the water from the red planet's atmosphere. This is SpaceTime. Coming up later in the Science Report, the growing effects of climate change becoming more and more apparent, and a new study shows that people with manipulative tendencies are more likely to believe in conspiracy theories. All that and more, still to come on SpaceTime. An Ariane 5 ECA heavy lift rocket has carried 2 new satellites into orbit. Arianespace Flight VA249 blasted off into clear blue skies from the European Space Agency's Kourou spaceport in French Guiana. The mission's payload included the Intelsat 39 and EDRS-C telecommunications satellites, which were both placed into geostationary transfer orbits.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage du Vulcain. Allumage des EAP et décollage. De la manœuvre en roulis. Les paramètres bord sont nominaux.
Right on time, Ariane 5 began her mission lifting off from the ground here in French Guiana with a lot of fire and with 2 new satellites rising into the bright blue sky. Exhaust flames of gold. The 2 boosters providing 90% of our thrust right now, propelling the launcher along her trajectory at an ever higher velocity. 775 tons at liftoff, hard to believe. But to get that sort of mass off the ground, you need a lot of push. She's burning 5 tons of fuel every second. 2.5 tons are burning every second in each of the boosters. Plus, the core stage, the middle stage, burning another 300 kilos of fuel every second. Ariane 5 is now following the program in the onboard computer, which gives all the orders, including stage separations. Ariane on her way east across the Atlantic. Right now, the first flight phase, the single first stage engine and the 2 boosters are burning. Boosters burn just over 2 minutes.
La propulsion est nominale, la trajectoire est nominale, tous les paramètres bord sont normaux.
The DDO says everything is perfect on board, and he's announced the separation of the boosters, the flames of the 2 boosters flaming out in the bright blue sky. The single first stage engine is burning now, taken over from the boosters. The boosters will fall.
La propulsion est nominale, la trajectoire est nominale, tous les paramètres bord sont normaux.
DDO says everything is nominal on board. The boosters fall 500 kilometers from shore into a protected area. Our altitude, 104 kilometers. Our speed, 2.27 kilometers per second. The speed we need to inject the satellites, roughly 8 or 9 kilometers per second, as we've separated the fairing.
Built by Space Systems L'Oreal, the 6,600-kilogram Intelsat 39 will cover broadband networking and video distribution services across Africa, Europe, the Middle East, and Asia in both C and KU bands. It's the 61st satellite launched by Arianespace for Intelsat and will replace the Intelsat 902, which was also launched by Arianespace way back in 2001. The European Data Relay System, or EDRS-C satellite, is the second node of the 4-satellite Airbus Space Data Highway Network constellation. EDRS uses laser technology to relay information and data between satellites, spacecraft, aircraft and ground stations, thereby cutting the time needed for satellites to deliver information to the ground. The system's designed to provide almost full-time communications even with satellites in low Earth orbit that often have reduced visibility from ground stations. It makes on-demand data available for services such as rescue workers who need near real-time satellite data in emergency situations. This report from ESA TV.
At Europe's spaceport in Kourou, the new EDRS-C satellite is undergoing final preparations before its launch. An Ariane 5 will lift the satellite into geostationary orbit, where it will join EDRS-A, which was launched in 2016 as a hosted payload on Eutelsat 9B as part of the European Data Relay System. The European Data Relay System is a collaboration between ESA and Airbus Defence and Space, aiming to improve and accelerate data transmission from low Earth orbiting satellites to the ground. From their geostationary orbit, EDRS satellites can both see the low orbiting imaging satellite as well as the ground stations. Data from the imaging satellite is sent via a laser link to EDRS, which then transmits data via radio frequency to the ground stations. This process allows for longer and faster data transfers, creating the space data highway.
EDRS is called a space data highway because it's likened to an optical fiber in the sky. It's a highway through which data travels at enormous speeds. In the case of EDRS, at up to 1.8 gigabits per second. And if you compare this to a conventional internet connection at home, you can say that it's about 100 times the speed that you get with your internet connection when you surf at home. So that's a real highway for data in space.
The main features of EDRS are a high transfer rate achieved by the use of laser technology and a near-permanent availability, a result of the satellite's bird's-eye view from geostationary orbit. This results in a quasi-real-time availability of the data on the ground, a step forward from conventional systems that only allow data transfers for 10 out of every 90 minutes. EDRS is the first commercial system in the world to use optical communication between satellites. While the system has been jointly developed by ESA and Airbus, it is the latter who will operate the service.
The launch of today's EDRS-C satellite is a fantastic opportunity for enhancing our space data highway system. With Space Data Highway, Airbus is the first connectivity operator of laser communication services. Already today, Space Data Highway links all the 4 Copernicus satellites near real-time to the Earth, and it will allow, with the second satellite, to have near real-time data of 2 Earth observation satellites at the same time. A fantastic innovation. Also, it will be, of course, a backup of the first satellite in case we have a problem.
EDRS-C is the first dedicated EDRS satellite. It will provide additional capacity to the European Data Relay System, but also improve its robustness and further increase coverage. Once both nodes are fully operational, EDRS will be able to relay at least 50 terabytes of data every day. Today, ESA and Airbus are already working on a third node, EDRS-D, which will be positioned over the Asia-Pacific region and mark another step towards worldwide use of this breakthrough technology.
The ultimate goal will, of course, be to achieve global coverage so that we can transmit imagery that is taken anywhere in the world to Europe within quasi-real time, meaning almost immediately.
And there is a great future in using EDRS. With our new Pléiades NEO satellites, 30 centimeter resolution coming soon, from 2021 onwards, we will be providing you with more high-resolution, near real-time data for Earth observation applications. And I'm very proud of that.
With higher resolutions and better imaging techniques, the amount of data provided by low Earth orbiting satellites will only increase further in years to come. Therefore, both ESA and Airbus are convinced that optical communication in space is a key technology, allowing us to fully exploit these vast amounts of data. EDRS is the beginning of a new era in space-based telecommunications, and the launch of EDRS-C is another step towards the completion of the space data highway.
And that report by ESA TV included ESA's EDRS project manager, Michael Whitting, and Evert Dudok, the head of communications, intelligence and security with Airbus Defence and Space. Russia has launched another classified military surveillance satellite from its Plesetsk Cosmodrome 800 kilometres north of Moscow. The launch aboard a Soyuz 2.1V rocket, equipped with a Volga upper stage, placed the spy satellite into a near-polar orbit with an altitude ranging from 365 to 855 kilometers. The top-secret payload's understood to include an Inspector-class spacecraft, which is designed to approach, monitor and study other satellites. The clandestine probe's also equipped with high-resolution optical imaging systems to undertake surveillance missions. Moscow describes its Soyuz 2.1V rocket as a light carrier. It's based on the current Soyuz 2 launch vehicle, but without the usual 4 strap-on liquid-fueled first-stage boosters, and using a single kerosene-fueled NK-33 main engine, replacing the usual 4-nozzle core stage engine flown on other Soyuz configurations. This launch was similar to that of another Soyuz 2.1V flight back in June 2017. It also deployed a secret payload into a similar orbit. That flight carried a military spacecraft designed to collect geodetic measurements to update and improve Russian nuclear missile guidance and targeting systems. That spacecraft also later released the small Inspector-class satellite designed to approach and study other satellites in orbit. Meanwhile, China's busy end-of-year launch schedule is continuing to ramp up without any signs of a let-up in flights. Chinese commercial launch company X-Space used its Kuaizhou 1A solid-fueled rocket to carry the KL Alpha-A and KL Alpha-B microsatellites into orbit from the Zhuquan Satellite Launch Center in Gansu Province, northwestern China. The 2 spacecraft will be used to test new Ka-band communication technology. Just a few days later, Beijing launched a Long March 3B rocket from a Zhaichang Satellite Launch Center in southwestern China's Sichuan Province, carrying another pair of Bidao-3 or compass navigation satellites. The 2 1,014-kilogram spacecraft are the 50th and 51st members of the Bidao constellation and are equipped with lightweight hydrogen maser clocks, phased array antennas for navigation signals, and laser retroreflectors. They were deployed into 21,500-kilometer high medium Earth orbits. The Bidao flight was followed just 5 days later by the launch of a Long March 4C rocket from the Taiyuan Satellite Launch Center in northern China's Jiangxi Province, carrying another Gaofeng Earth observation satellite. Beijing describes the Gaofeng 12 as a microwave remote sensing satellite capable of providing images with resolutions of under a meter. It'll join the growing Gaofeng constellation, undertaking high-resolution land surveys, urban planning, road network design, crop yield estimates, disaster relief, global belt and road projects, and allowing Beijing to keep an eye on the activities of other countries. The mission was the 320th flight for the Long March series rocket. And time now to take a brief look at some of the other stories making news in science this week with a science report. A survey of more than 300 people with close links to the Australian environment, such as farmers, graziers and birdwatchers, shows that they're already noticing climate change impacts on hundreds of species and ecosystems across the country. A report in the journal PLOS ONE found that generally the most common changes people in the survey attributed to climate change were plants dying, changes in plant seasonal effects, and changes in animal abundances. The researchers found that the overarching pattern suggests that people are more often noticing climate change losers, such as native species, rather than winners in their local areas. The authors say the observations were generally consistent with expectations from models predicting moderate to high degrees of change in biodiversity across Australia by 2050. Coral researchers have been working day and night across the Great Barrier Reef to complete a radically new approach to mass coral reseeding, successfully rearing millions of hardy coral babies following the reef's mass coral spawning event. The coral, I guess you'd call it IVF team, was led by Southern Cross University's Professor Peter Harrison, and it captured millions of coral sperm and eggs during the synchronized breeding event. The team then successfully reared and turbocharged the coral larvae with algae symbionts ready to replenish heavily degraded sections of the reef. Leaked Chinese government documents have shown how Beijing is using unprecedented mass surveillance techniques to develop and feed algorithms specifically designed to identify people for investigation based purely on their travel history and the type of messaging apps they use. The findings, reported in the journal Nature, are shedding more light on the country's process for detaining more than 1 million people in so-called re-education camps. One leaked intelligence briefing note describes how officials rounded up more than 15,000 people flagged by the algorithm in just a week and then placed them in internment camps. The Chinese embassy in the United Kingdom has called the leaked documents pure fabrication. 2 lion cubs are the latest find to set Egyptologists a-buzzing following a raft of exciting new discoveries. A report in the journal Nature claims the lion cubs were found along with other feline mummies and animal statues at a necropolis dig site south of Cairo. This latest archaeological news follows the discovery last month of 30 sealed coffins and their mummified human contents at a dig site near Luxor. A new study has found that people who believe in the supernatural and those who express manipulative tendencies are more likely to believe in conspiracy theories. The findings, reported in the journal PLOS ONE, are based on an investigation of the so-called dark triad of psychological traits: Machiavellianism, psychopathy, and narcissism. In a survey of 230 people, the authors report that alongside supernatural thinking, Machiavellian or manipulative and psychopathic, that is callous, emotionally detached traits, were the strongest predictors of conspiracy beliefs. However, they found no significant relationship between narcissism and a belief in conspiracy theories. The findings shed new light on the origin of conspiracy theories and how such beliefs gain traction. An anti-vaxxer has come up with a new con trick to try and discourage people from getting vaccinations from their local doctor. He enters the medical centre inferring but not actually claiming to be a government official, and then insists that any and all vaccination promotional material be removed immediately or further action will be taken. Ooga booga. Leaving the employees to think legal action would be pending. Tim Mendham from Australian Skeptics says the hoax's actions are concerning on several counts. Firstly, it could encourage other anti-science or anti-medicine proponents to carry out similar actions, but equally worrying was how compliant and unchallenging the clinic staff, including the doctor, were to the hoax's assertions that he had the authority to demand the posters be removed.
There's a story in Melbourne in which a anti-vaccination campaigner entered a medical clinic and basically went in there and said, "I'm required to ask you to take down your vaccination posters." And then he started quoting the Therapeutic Goods Administration. Now, he never said, "I'm actually from the TGA," but he did say, "I will have to ask you to take them down. I'm required for you to take them down. If they are not taken down, I will have to come back." And so he definitely gave the impression that he was acting in some official capacity. He actually then went in and spoke to a doctor and gave him the same message, and the poor doctor was a bit confused by it. And of course, he flashes this TGA stuff in front of the doctors, in front of the receptionists, and it doesn't say that at all. In fact, the TGA says doctors are not allowed to put promotional material of particular products in their waiting room, in their clinics, etc. But this is government-mandated information on vaccination, saying get vaccinated. It doesn't say which product. That's legal to do that. So this fellow who came in was bluffing his way through, claiming illegalities or some sort of breach of regulations when it wasn't, and he's filming it all. Now, he's filming it presumably with a concealed camera as he's wandering around the clinic, and there's people there, there's patients there, women, men, children, etc., sitting down there waiting for their turn to go see a doctor, and they're being filmed. So he's filmed receptionists. A lot of that, yeah. Absolutely, and they might not want to be identified as sitting in the clinic, you know. And then he films the staff, the receptionists, etc., walking around the waiting room, taking down these posters, and he's saying, "There's another one over there. There's another one over there." It's not just brazen; it's false representation. It's using a concealed camera, and it's quite possibly...
It's against the Listening Devices Act as well.
That's right, absolutely, yeah. And it's quite possibly impersonating a government official, which you can be thrown into jail for.
This guy's obviously an anti-vaxxer. How dangerous is this sort of an action?
The action is extremely dangerous. He's an anti-vaxxer. He's an actor as well, although it doesn't seem that good. But he's an anti-vaxxer, and on his Facebook page, he does actually have, or he did have links to the videos he filmed. He published them. There are other people saying, "This is great. What can we do about it? What can we do here?" In other words, there was indications that other people might be following suit. And therefore, you're going to get a bevy of anti-vaxxers going around impersonating people, insisting that posters are taken back. These are posters warning about pertussis in pregnant women. Women in their later stages of pregnancy can get vaccinated against pertussis, whooping cough. These are important issues, and to have this information taken down is reckless.
That's Tim Mendham from Australian Skeptics. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcasts, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audioboom, from SpaceTimeWithStuartGary.com, or from your favourite podcast download provider. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web that I find interesting or amusing. just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram. On Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary, and you can also find us on the SpaceTime with Stuart Gary YouTube channel. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.